everyone. We are here to give a presentation on IoT based home automation solution. First of all, we would like to thank Emertxe for making us be a part of this internship. Coming to the topics, the contents we are going to cover are C programming, IoT, embedded systems, microcontroller. C programming, it is a general purpose language used efficiently in various domains. Let me discuss with the structure of a simple C program, starting with command lines which are optional and these are not a part of execution. Pre-processed directives hash include stdio.h which contain printf and scanf statements. This program prints hello world on the console. The topics that we have covered in this internship course are data type, modifier and qualifier, conditions and loops, operators, arrays and pointers, strings, function, storage classes, preprocessors. And the next topic is Internet of Things. Internet of Things is a collective network of connected devices. It is a technology that facilitates communication between devices over the internet. IoT system works through the real-time collection and exchange of data. Some of the applications of Internet of Things is automobile, manufacturing, transport, business, like health monitors, smart cars, buildings, and home automation.
Coming to the embedded systems, an embedded system is a combination of computer hardware and software designed for a specific function. They are low cost, low power consuming small computers embedded in other mechanical or electrical devices. Generally, they comprise a processor, power supply, memory, and communication ports. Let's look at the flow graph of the embedded systems. This flow graph consists of a sensor, AD converter, processor and ASIC, DA converter, actuator and memory. The sensor measures the physical quantity and converts it to an electrical signal which can be read by an observer or by an electronic instrument. The AD converter converts the analog signal sent by the sensor into a digital signal. The processor and ASICs process the data to measure the output and share it to the memory. The DA converter converts the digital data fed by the processor to the analog data, and the actuator compares the output given by the DA converter to the actual output and stores the approved output. The applications of the embedded systems are electronics, medical field, automotive industry, telecommunications, security systems, and robotics. The examples of embedded systems are CAT scanners, implanted heart monitors, electric vehicles, and household appliances. Coming to the microcontroller, the topics covered are ADC block and DAC block, timers and counters, PWM, processor, memory, and input output ports, microprocessor versus microcontroller, RAM, ROM, and its types. Let's take an overview of our project. This project provides an IoT based home automation solution using Arduino UNO board. Blink IoT mobile application is used to control the devices remotely. It controls the lights, temperature of the home, and inflow and outflow of water in the water tank. The objectives of our project are they connect the home appliances to the Arduino and integrate it with Blink IoT app using Blink Cloud. Control lights, temperature of home along with the level of water tank using the mobile app. And to obtain the notification about the status of home on the mobile phone.
Why we should use home automation? Sometimes there comes a problem where the home appliances are not being monitored. The solution for this problem comes out to be home automation. Home automation enables people to control most of the devices remotely, such as volume of water present in the water tank, garden lights, temperature of home. Arduino. Arduino Uno is a microcontroller board based on the ATmega 328P. It has 14 digital input-output pins, 6 analog input-output pins, a 6 MHz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. It can be programmed using different IDE, Arduino IDE, which is used in this project. Arduino IDE supports C and C++ languages. PiximLab. PiximLab is an open source real-time emulator of development boards with integrated MPLab. It supports some Pixim microcontrollers and it has integration with the Arduino IDE for programming the board microcontrollers. Blink IoT app configuration. Blink IoT application which allows user to control the devices according to user's wish. How to create new template, how to add device, how to select and add data stream, how to create icon, how to include Blink library. These are the applications which are available in the Blink IoT application, which is a mobile application. Light dependent resistor. Light dependent sensor is a light detecting sensor that detects the light that falls upon it. The photoresistor is a high light controlled variable resistor. The resistor of the photoresistor decreases with the increasing incident light intensity. The LED lights are connected to the LDR via the ADC. The ADC converts the analog input by the LDR into its equivalent digital form, which is then converted later by certain formula from 0 to 255 as upper bound. Based on that, we glow LED. On the graph, we take light intensity on x-axis, resistance on y-axis, and resistance decrease with decreasing light intensity.
Let us look at the working of the garden light control. The LDR sensor and the lights are connected to the Arduino UNO. The properties of LDR sensor is to accomplish the controlling of garden lights. During the day, the outdoor light is maximum, and so the LDR sensor detects the light and the garden light is turned off. Whereas at night, the outdoor light is very low, so the LDR sensor detects the light and the light is turned on. Let's look at the temperature sensor. The temperature is recorded using LM35 sensor which reads analog value. This value is converted into binary value and later actual temperature is calculated using the obtained value of the voltage. The sensor does not require any external calibration or trimming to provide accuracies. Let's look at the temperature control system. Let me explain you this diagram in detail. The temperature control system consists of a heating resistor, an LM35 temperature sensor and the cooler. Analog value of temperature is obtained from the temperature sensor LM35 and displayed on the CLCD after converting it into a digital value using ADC. Control the temperature of the system by turning on or off the heater and cooler through the Blink IoT mobile app. Now let's move on to the water tank inlet and outlet valve control. So it reads the volume of the water in the tank through serial communication and it displays it on the CLCD. It controls the volume of the water in the tank by controlling the inlet and outlet valve by spending commands through serial communication and display the volume of water in the tank on CLCD and also in Blink IoT app. The tank refills itself when the outflow exceeds the threshold of minimum value 2000 liters and it stops filling when the tank is full at 3000 liters. Gives notification to the Blink IoT app.
Concluding this project provides a solution of monitoring and controlling home appliances and certain devices remotely. Using Blink IoT application and Pixim Lab simulator, home automation project is simulated where LED, temperature system, serial tank, light, heater, cooler and water tank are considered. Blink IoT application allows users to control these devices according to users' wish, thus accomplishing home automation. Thank you. Once again, thank you Emertxe for giving this opportunity to be a part of this internship. Thank you.